Looking at finding the slope of a tangent line of a function at a point. So we're getting into some of the application of a limit today. And this is some more stuff that you'll be seeing in calculus, those of you that are moving on with me. So, tangent line problem and the derivative. So the first thing we need to talk about is what is a tangent line. Anybody know what a tangent line is?
The line that tangent.
Like as far as a circle goes?
Just what's your experience with the word tangent?
Great, opposite over pain, tears.
And a line.
It's the longest one.
What?
It's the largest one in triangle? No. Is that?
So when line touches the circle at exactly what
It's been too long.
is
Side over cosine.
Okay, and it's really not going to be related to trig. So what is your experience with the word tangent line from geometry?
it's a line that touches the circle but doesn't go in it.
Alright, there we go. Tangent line from geometry is a line that touches the circle but doesn't go in it. So here's an example. Here's an example of a tangent line. So so I've got this function. I've got the curve function, and then I have a tangent line down here on the bottom. Okay? So why is that considered a tangent line?
It touches at one point or one.
It touches but does not, we're going to say, cross. So a tangent line is going to be a line that touches a function at a point but does not cross that function. That's a tangent line. Okay? Now, if this function happened to continue on and somehow come back down here and then come back up, I don't care whether or not it touches again somewhere else. All I'm cared about is if it touches at one point and does not cross at that point. It can cross somewhere else, but all that matters for it to be a tangent line is that it touches and does not cross at a point. So if it does that somewhere, it's called a tangent line. Okay? So a tangent line is a line that touches a function at a point but does not cross at that point. Okay? It can cross somewhere else, but just not at that point. That's a tangent line. So we are interested in finding the slope of a tangent line. Now, obviously, how many tangent lines does this function have? Nope. An infinite number of tangent lines. I can draw a tangent line anywhere I want to on here, as long as it does what? Touches, but does not cross. So there are an infinite number of tangent lines we can draw. Okay? So what we want to do today is we want to figure out how to find the slope of a tangent line at any given point on a function. So if we were going to draw a point right here, okay, let's say that point is 3, 4. We want to be able to figure out if I drew a tangent line at this point 3, 4, what would its slope be? Okay, that's what we want to be able to do today. Okay, and that's what we're going to achieve. All right, so to get started, though, we are going to start with a secant line. What do you guys remember a secant line is from geometry? Here's an example of a secant line.
Cross.
So secant line is we got 2 points on the function. We're going to draw a line between those 2 points. That gives me a secant line. Okay? And we are going to start with a secant line and use a secant line to eventually get us to a tangent line. Okay? So, we're interested in slope. What do you guys remember about slope, or how to find slope? Good. I'm glad. Good, Skye. So,
I couldn't tell you, but I can do it.
y2 minus y1 over x2 minus x1. You should remember that as your slope formula. Okay. So, in order to use this slope formula, what do I have to have? I have to have 2 points. I've got to have 2 points, which I have right here. So what we're going to do is we're going to generically label those 2 points. That way we can come up with an equation we can use for any given point. Okay? So first thing we're going to do is label this point down here on the bottom left. So what would be a generic way of labeling that point?
0, 0.
Without numbers.
It's X, Y.
X and Y. Okay?
And Y labels them at all.
You'll see.
That's what I'm.
Okay, X, but I don't want to use Y. Let's say this curve, let's say that curve, we're going to call that curve f of x.
Okay.
So if that curve is f of x, what can I label the y value as? I can label it as f of x. Because if this point was 2, what would I do to get the y value?
Okay.
I plug 2 into my function, which would give me f of 2. Okay, which would eventually give me my y value. So our first point we're going to label as x and f of x.
So why can't you put a y in there? If f of x is gonna give you y.
You'll see.
Just wait for it.
We need it to be labeled this to get to the formula we're looking for today. Alright, now how is this x value right here related to this x value?
They're cousins.
Okay? Being serious.
I guess.
How is the x value on the right related to the x value on the left?
To the function.
In size. The x value on the right, how is it related to the x value on the left in size? It is larger. Okay? So, let's say this was some distance right here. We're going to call this distance h. If I start out at the x value of x, and then we move over h, what is my new x value called? X plus h. So my new x value would be called x plus h. Can everybody buy into that?
Yep.
So for instance, if I had an x value of 3 here, I moved over 4, that means my new x value would be 7. I took my initial x value plus what I moved to get my new x value. Same thing here. My initial x value is x. I moved over h, so that means my new x value is x plus h. So this point right here, the x value for it is x plus h. So what are we going to call the y value for it?
F of x plus.
F of x plus h. Very good. So the y value would be called f of x plus h. Okay? Now that we have those points labeled, let's put them back into our slope formula over here. Okay, so what do I put in for y2?
F of x plus h.
F of x plus h. What do I put in for y1? F of x. On the bottom, what's x2? X plus h, and what's x1? X. Okay, so I get f of x plus h on the top, minus f of x. What does the denominator turn into?
H.
Just h. So, what does that formula right there represent?
The slope of the tangent
No,
Secant.
secant line. So this formula right here,
It's labeled wrong, that's why.
that formula right there helps me get the slope of the secant line. Okay? It is also called something else. It is called the difference quotient. Why do you think it's called the difference quotient?
Because it has both subtraction and division.
Because I have both subtraction and division, so that's why it's called the difference quotient.
Sweet.
Okay? So the difference quotient produces the slope of the secant line. Yes.
Why is your y f of x plus h? Because the y is going up, and going up isn't the value of h.
But if I had the point 2 right here and f of 2, okay? How did I get f of 2?
You put two.
I plugged 2 in for x into f. So if this over here would be 5, what would my y value be?
Okay.
F of 5. Well, in this case, we don't have numbers to plug in. We have x plus h to plug in, so that's why I get f of x plus h.
Look at me when you're talking.
No.
Alright, so I have the formula that gives me the slope of the secant line, which we're also going to call the difference quotient. But that's not what I'm interested in. What am I interested in? I'm interested in finding the slope of the tangent line. So we're going to do something to the slope of the secant line to get the slope of the tangent line. Alright? So, let's take this right point, the point over here on the right, and let's move it towards the point on the left, and let's notice some things. Okay, what's something that is changing as I move that point to the left?
The slope.
The slope is changing. What else is changing?
Distance.
What distance? What do you mean distance?
H.
H is changing. So as I move to the left, what is happening to H?
Decreasing.
H is decreasing. And where is H eventually headed?
0.
0. What does that sound like?
Undefined.
A limit. We're interested in our limit as H does what?
0.
Gets to 0. And if I take the limit as H gets to 0, what am I going to end up with? I'm going to end up with a tangent line. So I've got my secant slope, my H is getting smaller, eventually my H goes to 0, and when H goes to 0, I get the slope of the tangent line. Okay? So that's what we're interested in. We're going to start with the secant line slope, which is f of x plus h minus f of x over h. That represents what?
The secant line.
The slope of the secant line. But then when I do this,
That's when the X.
the limit as h approaches 0 of that thing, it turns into what gives me the slope of the tangent line. Okay? Now, let's talk about some terminology again. We said this inside part was called what? The difference quotient. Okay? When I put it all together, what do you think it's called? The limit of the difference quotient. Very good,
I
Gabe.
am on fire today.
So the limit of the difference quotient, and it has another name as well, and that is called
Or something wrong.
the derivative. Okay?
So,
So that is our derivative.
My hopes to do it.
Yes.
so that whole function right there is going to give us tangent.
It's going to give us the derivative, and the derivative is going to be the function that gives us the slope of the tangent line.
Ah, okay.
Alright. Is it hot in here?
So that is my derivative. In order to get the slope of a tangent line, I first must have a derivative. Once I have my derivative, then I can find the slope of the tangent line. So that's what we're going to do next. We're going to do 2 examples of that to be able to find slopes of the tangent line. So, let's say I've got my function f of x equals x squared. And I'm interested in being able to find slopes of tangent lines of x squared. In order to find slopes of tangent lines of x squared, what do I first have to find?
Slope of the secant line.
What was that thing?
The
Yes,
derivative.
thank you. The derivative. In order to find slopes of tangent lines, I first have to find the derivative. The derivative is what's going to give me my tangent line. So, anytime we're finding a derivative right now, we're starting out with the limit of the difference quotient. So that's what we're going to write down every time, because this is something we need to memorize. Okay, we're going to start with that. So we write that down every time, and then we have to replace these 2 pieces on the top, depending on the function that we're dealing with. So I'm going to have the limit as h approaches 0. The denominator is always going to be h. Does anybody have any idea of what I replace f of x plus h with? Here.
Squared plus h.
There we go. As Hunter says, that's x plus h squared.
Yeah.
Because what do we do with what's on the inside? Where do we plug that in at? We plug that in for the x. If I wanted f of 3, what would I do for 3? What would I do with the 3 if I wanted f of 3? I plug 3 in for x. So I'm wanting f of x plus h, so I plug x plus h in for x. And it gives me x plus h squared.
Oh,
So, what does f of x equal? That equals x squared. So the right side is always going to be what? The right side is always going to be whatever your function is. Okay, the left side is always going to be x plus h plugged into your function. Alright? So, I'm now set up. And anytime I want to find the limit algebraically, what's the first thing we always do? Plug in. So I'm plugging 0 in for what?
H.
H, because we're going H to 0. So I plug 0 in for H, which gives me x squared minus x squared, which is 0, and I plug 0 in for H on the bottom, which also gives me 0.
So now we have to go back and do.
So what form is that called? Indeterminate form. What are our 3 strategies right now that we use to deal with indeterminate form? Multiply it out. There you go. So which one do I want to do in this case? Multiply it out. We only want to use conjugate when we see what? A radical. If I don't see a radical, I'm not going to use the conjugate. So the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. So this right here is what I get when I multiply x plus h squared out. Now, once you multiply it out, once you factor, or once you multiply by the conjugate, something, and anything with it without an h, if it does not have an h attached to it, it should cancel. So what does not have an h in the numerator?
X squared.
X squared. So that should cancel. Does it cancel? Yes, it does. So once you multiply it out, multiply by the conjugate, anything in the numerator that does not have an h in it should cancel. Then what can we do? I still can't plug in 0
Don't
yet.
plug in 0, it'll still get you in
We
five.
divide by H.
Divide by H.
I want
Factor
to
out
One of the
factor
h's
an h
cancels.
out. So 2x plus h over h. Okay? So
Okay.
anything without an h is going to cancel. Then the next thing I do is always factor the h out. And once I factor the h out, it always cancels with the bottom. And then as soon as I cancel h, then what do we do?
Okay. Now
You plug it in. So I'm going to plug 0 in for h, and I end up with
2x.
2x. Now, what is 2x?
Not the derivative.
Yeah, what did we say this thing equals? The derivative. So this is the derivative.
Yeah.
Derivative. That is the derivative. And we use the derivative to find what? Slope of the tangent line. So, let's choose one. Let's say I've got the point 39. The point 39 is on that function. And I'm interested in what is the slope at the point 39. So what do I do to find the slope of the tangent line at the point 39? I plug in my x value. Very good. So I plug in 3 to this, and that means my slope is? My slope is 6. That is correct.
So,
That's easy.
will the problem, does it give us the graph of it, or it will just give us like the point?
It's going to give you a function, and if it wants a slope, they're going to give you a point as well.
Okay.
So they're going to give you the function, and they're going to give you the point they want the tangent line at.
Okay.
This is slope at. Alright, so let's graph this. So new document, no, we want to graph x squared. Alright, so we're interested in the point 39. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. So the point 39 is right there. So my tangent line is going to be about right there, and I know the slope of that tangent line is 6. So the slope of that tangent line is 6. Now let's look at another point, because there's something we want to learn. Alright, let's pick the point -39. What's the slope of the tangent line at the point -39? That is -6. So my slope there is -6. So let's go back to the graph. Alright, so there's 9. We come over here. There's my tangent line, and I know that slope is -6. So, We want to figure out something that the slope of the tangent line tells us about our function. What is my function doing differently on each side here? What is my function doing on the right over here where my slope is 6? And what's my function? So what is a math term for going up? Increasing. So over here, my function was increasing. Over here, my function is decreasing. Well, I don't care about that. That's not what we're looking for. We're looking for the slope of the tangent line, and what does the slope of the tangent line tell? So if the slope of the tangent line is a positive number, what does that tell me about my function at that point? It is increasing. If the slope of the tangent line at a point is negative, what does that tell me about my function at that point? It is decreasing. What's something that's not increasing or decreasing? 0. So if the slope of the tangent line is 0, what does that tell me about my function? Right. In this case, where would my slope be 0? At the bottom down here. What's going on with my function at the bottom? What is that spot? What can we call it?
It's a minimum.
It's a minimum. Okay, so that's another thing we use tangent line slopes for, is to help us find a minimum or a maximum. Because if my tangent line slope is 0, that means I might have what at that spot? A minimum or a maximum. So those are some of the quick uses of the slope of a tangent line. Let's try another one. Alright, so let's say we have f of x equals the square root of x, and I'm interested in the slope of the tangent line at the point 9, 3. So in order to get the slope of the tangent line at the point 9, 3, what do I first have to find? The derivative. And to find the derivative, what do we have to start with?
The limit
Limit of the difference quotient. Very good. So we start out with the limit of the difference quotient. So f of x plus h minus f of x over h. Then what do we replace? The what?
The top.
The top. Yes, the top has to be replaced. So what does f of x plus h get replaced with? Very good. The square root of x plus h. What does f of x get replaced with? Square root of x. Alright, that's where when you do this on a quiz or a test, that's where your first point comes from, is plugging into the difference quotient. If you can show me you can plug in, then you get your first point. Alright, what should we do at this point?
or plug in.
We should plug in. So if I plug 0 in for h, that gives me the square root of x minus the square root of x, which is 0. I plug in 0 for h in the bottom, which also gives me 0. So right now I have to do one of 3 things. Which one do I want to do in this case? Multiply by the conjugate. So square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Alright, so what do I end up with in the numerator? X plus h minus x. And what did we say? Anytime I multiply out or factor or multiply by the conjugate, what should happen next?
Cancel off
Anything without an h should cancel. So that means the x's have to cancel. Do they cancel?
Yes.
Yes, my x's cancel. Okay, what can I do next?
Cancel H.
The h's can cancel. And here's what people like to give me when they cancel the h's. People like to give me that. But what should it be? Should be 1 over. So make sure you give me 1 over. And what do we always do after we cancel the h's? Plug in. So we're plugging 0 in for h. So I plug 0 in for h, which gives me the square root of x plus the square root of x, which is 1 over 2 square root of x. What is 1 over 2 squared root of x? The derivative, which allows me to find the slope of the tangent line. So, I want the slope of the tangent line at the point 9, 3. So it gives me 1 over 6. So before I go to the graph, what do I know my function is doing at the point 9, 3? It is increasing. Why is it increasing?
Positive.
Because my slope is positive. So let's go to the graph. Alright, so we're going to the point 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3. There's my point. So my tangent line would be somewhere in there. What do I know about the slope of that tangent line? It is 1/6. Okay. Is my function increasing there? Yes. Since my slope is positive, I knew my function was increasing there. What's something that this function will never do?
Be negative.
It will never decrease, which means my slope can never be
Negative.
negative. So let's go back to the slope and talk about why or how we could have known that my slope was never going to be negative. Look at my derivative. Yeah. What does the square root of x always have to be?
Positive.
It always has to be positive. Okay? Which means this has to be positive. And if my derivative is always positive, that means my function has to always be increasing. Okay? Now, my slope at this point is 1/6. Take a look at what my function is doing when my slope is 1/6. Let's go back to my first one. We had a point here, and my slope was 6. We had another one here, and my slope was -6. What's something else we noticed that the slope can tell us about our function?
What it's, the shape.
What do you
Tell
mean
us
by
how
that?
wide it's going.
What do you mean about the shape?
Well, you have parabola going up in the y values, and then you had the half parabola going to the x values.
So what does the slope tell me? I'm not seeing the connection that you're making. What connection are you making?
What shape it's gonna appear on the graph.
What do you mean by shape?
I don't know.
I think you're close, but you're not what I want you to get. What else can the slope tell me about my function besides the fact that it's increasing or decreasing?
The size.
What do you mean by the size?
Like if it's a parabola, like how wide or narrow it
You're
is.
getting closer. You get warmer. There we go. Very good, Sakaya. She says that'll tell you how steep the function is at that point. Okay? Notice what's going on over here. What's up with my steepness on 6 and -6?
It's
It's pretty steep, right? And over here, my slope was 1/6, and if I pull that back up, what do you notice about the steepness of it? It's not very steep. Okay? So, the slope can also tell you how fast the function is increasing or decreasing. So the larger the number of the slope, what's my function going to be doing?
Increasing.
Increasing or decreasing fast. The smaller my slope is, the slower my function is increasing or decreasing. So if you've got something like 1/6, you know it's going to be fairly flat and it's not going to be increasing very fast. If you've got something like 6, it's going to be pretty steep and it's going to be increasing faster. Okay? Alright, so let's put a recap on this. F of x plus h minus f of x over h. What is that thing called? Difference quotient. When I take the limit of the difference quotient, that turns into the derivative. So when I evaluate that, I end up with the derivative. If I want the slope of the tangent line, what do? Plug the x value into the derivative, and that will then tell me the slope of the derivative, or the slope of the tangent line. If my slope is positive, what does that tell me? My function is increasing. If the slope is negative, that tells me my function is decreasing. If the slope is a larger number, that tells me I am Increasing or decreasing fast. If my slope is a smaller number, that means I'm increasing or decreasing slope. Okay, so that's what I want to learn. So if I'm going to find the derivative, what do I have to start with?
The difference quotient. No,
The limit of the difference quotient. Because the difference quotient just gives me what?
The slope of the,
Slope of the secant line. I'm interested in the tangent line, so that means I've got to take the limit of the difference quotient. Alright. Quiz tomorrow. When you get done with the quiz, I'll probably have some work for you to get started on what we did today. Since it is a quiz, you get one sheet of